Hello guys, this is Mr. Gonzalez or Mr. G. I'm going to show you guys how to use these equations. Generally, last semester we did get these equations from the graphs in one of the labs that we did. Okay, and so when we did that, we obtained these, but then what Miss Black really liked us doing is she really wanted us to use the graphs, for a velocity versus time graph. She wanted us to use a velocity versus time graph, and then you could say that the slope was the acceleration, and then to use the graph instead of an equation like that. Okay. Now, that worked out just fine, right? We did perfectly fine learning that, but what if we got a question like this? A person from rest, they accelerate uniformly for 20 meters within, that's a 3.4, that's not 34, that's a 3.4 seconds. So it creates a little bit of an issue where we want to create a graph and get right on the dot for 3.4 seconds, because 3.4 seconds is, it's going to be between 3 and 4, but some people might have a hard time, approximating that. And Ms. Black didn't really want us to use the equations. She wanted you guys to strictly be on graphing. But I realize in these worksheets, there's a lot of use of these. In this unit, there's a lot of use of these equations, and I'll show you guys how I go through my problem solving using these equations in order to solve. Okay. So again, it says so I'm going to go through the steps that I go through in general of how to solve problems like this. Okay. So first I read the question maybe once or twice. A person from rest accelerates uniformly for 20 meters in 3.4 seconds. What is the acceleration? Okay. I know what it's giving me. Okay. What I usually start off with on a problem like this is I list the different types of variables. Let me actually define some of these for you real quick. Okay. Delta x, that's our displacement, right? V with that 0 on the bottom, that's what we call like V naught. Some people call it that. It just means initial velocity. So if I were to go to right here, and these two mean the same thing. These two both mean initial velocity, the two symbols. Okay. So our final velocity and our time and our acceleration. Now, what I'm going to do is I always put down what am I given. Okay. I'm given that they start from rest, so they start from 0 meters per second. I'm given that they accelerate uniformly, so we're going to find the acceleration, right? Maybe. It says they accelerate uniformly for 20 meters in 3.4 seconds. That does not mean that the final velocity is 20 meters divided by 3.4 seconds. No, that's not right. Okay, this is not a constant velocity. Okay, they say it's for 20 meters, so they go about 20 meters. You got to be careful when you read these. And they do it for 3.4 seconds. Okay, so that's everything we got from our question. Okay, next what I'm going to do is I'm going to say, okay, what's it asking me? It's asking me for the acceleration. So I don't really need this, but it is asking me what the acceleration is. So this is what I do next, is I come over to my equations, and I look at them, and I say, okay, which one has to do with delta x? Because I have my displacement. So which one has to do with displacement? This one. Awesome. Does it also have to do with the initial velocity? Yes. Does it have to do with the time? Yes. And what's most important is it has to do with the acceleration. Because look, we want the acceleration. So this equation right here has to do with the acceleration that we're trying to find, the time, and the other conditions that we have. Okay. This one also has delta x in it. This one also has displacement in it. And it has to do with the acceleration, and it has to do with the initial velocity. But this one has to do with the final velocity, right? We don't have that. We don't have the final velocity, so we're not going to use that second one. And this third one, we also do not have our final velocity, so there's no point in using this one. Okay. So this is what we're going to do. Next, I always write down the equation or the formula I'm going to use. I always write it down so that I know exactly what I'm plugging my stuff into. Now, the one issue I've always seen people have is always making sure they keep that t squared in there right there. Alright? Because that t squared right there, you got students usually leave out the t squared in their calculations. And I'll show you what I mean. Okay? So, then I plug things in part by part. So, my delta x, my displacement is 20. Okay. The initial velocity, okay, my initial velocity is 0. My time is 3.4 seconds plus 1/2 of my acceleration multiplied by 3.4 squared. Usually at this step, students forget to write that down, and that's where they forget the squared in there. They usually forget to bring it in right there. Okay. Let me grab my calculator real quick. Okay. So, 0 multiplied by 3.4 is 0. So we can kind of ignore this term mostly because the 0 plus times 3.4 is 0. So, as I said, we can ignore that. I'm just going to ignore units for the moment. 3.4 squared, if I plug that into my calculator, I get 11.56. Okay. So what I can do now is I can actually do 11.56 multiplied by 1/2. And I get, I'm going to put my work up here, I get 5.78, right? Because 11.56 multiplied by 1/2 is 5.78 times my acceleration equals to 20. Okay. If I divide by both sides to solve for my acceleration, those cancel out, and we get acceleration is equal to, I'm gonna 3.4602. So yeah, I do see we have 3.4 seconds, but that's just a coincidence. That's just a coincidence, okay? It's just a coincidence. So I get that. So I'm just gonna put my answer as 3.5 meters per second squared. Okay. So let me run it through with you again. Alright, that way so you have it rather clear as to the steps that I use in order to solve word problems like this. First thing I do is I read the question. So a person from rest accelerates uniformly from 20 meters in 3.4 seconds. What is the acceleration? There needs to be a comma right here. And then when I do that, I look at it and I list what am I given. Alright, I list, okay, I'm given my displacement, my initial velocity, and the time. It's asking for the acceleration. You need to make sure that you identify what it's asking for. Then, after I have all my givens and what it's asking for, I turn to the equations and I say which equation has to do with all the variables that I need and the ones that I have. This one right here happened to have all the variables that I had and that I needed. So I wrote it down. I didn't just plug things in right away, okay? I wrote it down so I can plug in my stuff right below it, so I can see exactly what I'm plugging in and where, okay? And then I plugged in my numbers. I calculated, and I kept on calculating, and I did my algebra, and I got my answer. Okay. If you would like, you can still use the graphs. I'm just telling you now, sometimes for the graphs, or sometimes we will have problems where the time that we have or the displacement or whatever numbers are not going to be whole numbers the entire time. Okay? This is just my intro video just to show you guys how to do a thing or two. Alright, that way so you can use these and get some practice on them as you work on worksheet 3.